So I know some of you probably are still working on it, but let's go over this thing here so that whoever stuck know what to do. So reminder from yesterday, reminder that this is what I want you to looking at is whenever we give you a problem, the first thing you want to focus in, the first thing that you want to focus in is you want to ask yourself, what is my C term? What is my last term? If my last term is positive, I'm thinking in terms of addition. In this case, my last term is negative. And if it's a negative, I'm thinking in terms of subtraction. And if you remember, this is what we need to do is we need to find the multiple of the last term. So what two numbers multiply together to give you 24? And if you in doubt, this is what you want to do is you want to list every single number out, right? We know that 1 times 24, 2 times 12, 3 times 8, and 4 times 6. 5 cannot go into 24. 6 times 4, as you can see, you repeat back your multiple. And if you repeat back your multiple, meaning there is no other number that can go into 24 evenly. Okay, so looking at this item here, we know that looking at this thing here, the two numbers that subtract, multiply to give me 24, but subtract to give me 5 is 3 times 8. And 3 times 8, and if you identify the 3 times 8, all we need to do is we fill in 2 of my parentheses. In terms of the first item, I put in my X. And again, I just put the 8 and the 3. Doesn't matter if you put the 3 first or the 8 first. What matters is the sign inside your parenthesis. Because we subtract, because we think in terms of subtraction, one of them is positive, one of them is negative, and reminder, the bigger number will get the sign of the middle term, while the other number will get the opposite. So the middle term that I have is negative, so the bigger number will get a negative number, and the other parenthesis will be negative. I mean opposite. Okay. So one thing is this answer and this answer is exactly the same. Okay. The order of the parenthesis does not matter. So if you put the x minus 8 in front of x plus 3 in front, the order doesn't matter. What matters is inside the parenthesis. Do not change it to x minus 3 and x plus 8. Because that operation, not operation, but that sequence will be wrong. Okay, so this is what we want to do, or this is what you want to ask yourself is, do I think in terms of addition, or am I think in terms of subtraction? That's the first key, as you will see later today or next week. Okay, so if you think in terms of addition, same sign. If you think in terms of subtraction, opposite sign. So in terms of this thing here, if you're looking at B, B is a little bit easier than A. If you don't see it, why I say it's a little bit easier, because 35, there are only 2 multiple that get you 35. 1 times 35 and 5 times 7. There's no other multiple, right? 2 cannot go into 35 evenly, 3 cannot go into 35 evenly, 4 cannot, 5 times 7, 6 cannot, and 7 times 5, you repeat it. Meaning there's no other number that can go into 35 evenly. Okay, so the only thing we have now is because of the 35 is positive, everybody see that now my answer, or what I have is, I have x5 and x7. Because 5 times 7 is 35 and 5 plus 7 is 12. And in this case, both of them are the same sign and both of them are positive. Okay, so this is what we have in the sense of factoring this thing out. And I mentioned this to you guys, and I mentioned this to my other student is, factoring is not hard. The hardest part of factoring is find a multiple. So in order for you to be good with factoring, you have to be good with your timetable. If you're not good with your timetable, it's just a little bit harder in terms that you take your calculator and then you divided by 2, divided by 3, and so on and so forth, right? So in the center of this thing here, hopefully you guys see that problem C is not hard either, because problem C, all we have is 1 times 77, 2 cannot go in an odd number, 3 cannot go into 77, 4 cannot go into this thing here, 5 cannot. The next number that can go into this thing here is 7 times 11. 7 times 11 is 77, and similarly to B, there's only, or this is the only multiple that we have, that's 7 times 11. And in this case, all I'm doing is I say x7 and x11. What are my sign? Because of this item here, they have the same sign, and both of them are, in this case, both of my parentheses will have negative. Okay, so this is the idea of factoring, and I saw a few of you guys type in the answer. I saw a few of you guys fill in the answer, and it's correct, right? Again, reminder, say that again. Reminder, in order for you to factor, again, if the last term is positive, we think in terms of addition. If the last term is negative, we think in terms of subtraction. And if it's subtraction, they will have opposite sign, because in order for you to add, they have to have the sign. In order for you to subtract, the two sides have to be opposite. So let's take a look at D, E, and F. So before you can attack the problem, I want you to find a habit and ask yourself, do we have the same sign and add them together, or do we have opposite sign and subtract them? Okay, how do we determine that? Reminder, to determine if you add or subtract, to determine that, you need to look at the last term. The first thing you want to look at is, don't look at the sign of the middle term, don't look at the sign of anything, just look at the sign of the last term for now. Okay, so in this case, you can see that D, you have to think in terms of subtraction. Okay, and in E, same idea go. In E, we have to think in terms of subtraction. And when you think in terms of subtraction, they need to be opposite sign. One have to be positive, one have to be negative. And again, in F, we think in terms of addition. And if we think in terms of addition, they have to be the same sign. Okay, so one thing is in D, if you guys stop, okay, and somehow, some way, a lot of students, when they come to see this problem, they get a little bit confused in terms of what number we're looking for. If you don't see, and if you want to, this is what you want to do is, remember, if there's no number in front of the Y, it's assumed to be 1. Okay, so it's 1Y. So if you want to, you can put the 1 there to tell you that we're looking for two numbers that multiply to give you 42, but subtract to give you 1. Okay, and again, if two numbers multiply to give me 42, subtract to give you 1, you have to think in terms of consecutive number, right? If something subtract to give you 1 is either 3 times 4, 4 times 5, 5 times 6, 6 times 7, 7 times 8. Something in that range, right? Because you cannot take 5 times 8, because 5 minus 8 would not give you 1, right? So when it's subtract to give you 1, is something consecutive. And hopefully you guys see that this is what we have, is we have Y7 and Y6. Why Y7 and Y6? Because 7 times 6 is 42, and 7 minus 6 is 1. And if you remember, if you subtract, the larger number will get the sign of the middle term, while the other number will be opposite. Okay, so this is what we have in terms of the first item. In terms of D, we think in terms of subtraction. 7 times 6 will give me 42, or 7 times a negative 6 to give me a negative 42, and 7 minus 6 to give me a positive 1. Okay, and hopefully you guys see that all of this problem is very identical, right? All of this problem, as long as there's nothing in front of the x squared or y squared, or in terms of this thing here, a z squared or the a squared, right? I give you z, a, and y. It is not try to confuse you. It's not trying to confuse you, but rather than tell you that no matter what the letter is, all we do is if you look at E, this is what you have is instead of putting X or a Y, we put in a Z, right? We break down the Z square and now we fill it. Make sure, ladies and gentlemen, make sure this is why, or this is the purpose of me giving you this problem. Looking at 24, we did 24 already. We know that 1 times 24 is 24. 2 times 12 is 24. 3 times 8 is 24. 4 times 6 is 24. 5 doesn't go into it. 6 doesn't go into it. Looking at this thing here, make sure, and again, I purposely give you this item here to show you that we cannot use the 4 and 6, or you guys don't use 4 and 6. Please do not use 4 and 6. Why? Because we think in terms of subtraction. Yes, I agree with you that 4 plus 6 is 10, and the 10 is in the middle, and that's what we have. But remember, because of the 24 is negative, we need one of them to be positive, one to be negative. If you take a look at this item here, and let's say whoever do this, don't copy this thing down, but let's say that whoever say, oh, -4 and -6 will give me 24, right? And -4 plus -6 to give me -10. But take a look at this thing here. If you were to check, and I think I did this yesterday, that if you were to check, do you agree that you need to take z times z to give you z squared, z times this item to give you a -6z, and if you take this item, you get a -4z. But what is a -4 times a -6? A -4 times a negative times a negative will give you a positive, and if you have a positive, do you see that this is what we have is, if you add this, you have z squared minus 10z plus 24. That is not my problem. My problem is -24, right? And if you say, oh, -24, well, all we need to do is just change in one of this item here. How about we changing this one of them to be positive to make this item to be negative? But if you were to change that, this thing will be positive, then this item will not give you 10z, but rather than -6 and a +4 or -4 and +6, you have to subtract them and keep the sign of a larger number. Okay, so in the sense, the good thing about this item here, ladies and gentlemen, the good thing about this item is there is only one combination, or they don't have any combination at all, and I will give you those problems in a bit. But looking at this thing here, we know that the 4 and the 6 does not work out. Okay, so looking at this thing here, because we think in terms of subtraction, hopefully you guys see that we have 12 minus 2, and 12 minus 2 will give us 10, right? We think in terms of subtraction, so we have to use the 12 and we have to use the 2. 12 times 2 is 24, and 12 take away 2 is 10. So everybody see why we cannot use 4 and 6, but rather than we have to use the 12 and the 2. And because we think in terms of subtraction, one of them is positive, while the other one is negative. So that is why, again, I give you this thing here so that you guys can see, that it's not the 4 and the 6. If you check this answer, if you try to check your answer, you can see that z times z is z squared. Z times 2 will give me 2z, and a -12 times z to give me a -12z, and a -12 times that to give me a -24. And as you can see, we bring down my z squared. What is a positive and a negative z? Well, if they have the same sign, we add. In this case, they have opposite sign, we subtract and kept the sign of the larger number. And the larger number is the 12, so I subtract to give me 10. And the 12 have a negative, so I keep on a -10. And again, I bring down my -24. As you can see, this is my question when you distributive them back. And that is what my answer will look like. My answer will look like, or in this sense, my answer is z minus 12 times z plus 2. So question in terms of E. And if you don't have question in terms of E, hopefully you see that F is pretty doable. In the sense that F, what do? All we do is we say A in one parenthesis, A in the other parenthesis. And again, is there two numbers multiplied to give you 20, but add together to give you 9? Hopefully you all say that we have 4 and 5. 4 times 5 is 20. 4 plus 5 is 9. And because we think in terms of plus, they both have the same sign. And in this case, they are both positive. So looking at this thing here, first of all, question before we move to the next one, before we move to the next set of problem question with this 3, how do we attack? How do we identify if we add them together, or how do we identify if we subtract them? Any question here, ladies and gentlemen? All right. If you don't have a question, let's take a look at this item here. This, we did not do this last time, but let's take a look at G. All right. Same thing go, if you look at this item here, you know that the first thing we want to do is we say, well, this item is positive. So we think in terms of addition, that's correct, ladies and gentlemen. But what is the difference between this set of problem versus the previous 6 problem that we have? What is the difference here? If you look at the previous 6 problem, there's nothing in front of the y square, the z square, or the a square, and there's nothing in front of the x square in this item here, meaning my x square is 1. So if you have this problem, this is what I want to point out to you guys is, this is our, in 6.1, our formula or our item that we have is something in this nature. This is our normal form. And our normal form, or the A in this item, is equal to 1. So this is our normal problem. If the problem is not in this normal form, the first thing you need to ask yourself is there any way I can make it into this form, where in front of the y square, there is no number. So if there is a number, and as you can see, G, H, and I, there is a number in front of the number. And also, if you identify that H, this is not the square, and this is not the square. So if you see that it's not in our normal form, the first thing we need to do is we need to factor out the GCF. And remember, what is a GCF? Well, the GCF is the greatest common factor. So if you look at this problem, before we can say, oh, I need to think in terms of 2 numbers multiplied to give me 36, you want to make your life a little bit easier and ask yourself, between the 3, 21, and 36, is there a number that can go into all 3 of them? And if there is, I can extract them out. And in this case, do you agree that 3 can go to 3? 3 can go into 21, and 3 can go into 36. And if that is the item, then I can take out a 3, and this is what I have left. I have 3 going to 3 will give me 1, or simply just y squared. 3 going to 21 to give me 7, y. And 3 going to 36 to give me 12. So again, this is the GCF. The GCF, the greatest common factor is 3. I factor it out. And now, as you can see, forget about the 3 now. What is in my parenthesis? In my parenthesis, This is my normal problem. Why I say normal? Because there is no number in front of the y square. And if there's no number in front of the y square, now everybody see that this problem is just like the problem we just did prior, right? This problem is just like a problem we did prior, which is 12 is positive. And if it's 12 is positive, is there two numbers multiplied to give you 12, but add together to give you 7? And hopefully all of you say yes, there is a 3 times a 4. And what do? All we're doing is this, ladies and gentlemen, we say y, and hopefully because it's adding, you say, well, they have the same sign, and in this case, they are both positive. The only thing different is whatever you factor out, you need to bring it out. You need to bring it down. You do not throw it away. So all you're doing right here is whatever you factor out. In this case, you guys told me that you factor out a 3. And if you factor out, you have to carry down. So as you can see, 36, we have to keep this 3 in consideration, so we cannot just attack the 36 like before. We can only attack the 36 if there's no 3 here. If the 3 is not there, then you say, okay, is there any number multiplied to give you 36, but add together to give you 21? But in this case, because of the 3, we have to use the 3 and take the 3 in consideration, okay? So looking at this thing here, let's take a look at H. So what is the difference in terms of H? And if you look at H, there are a few things that going on. The Z is not Z squared, it's Z to the 4. Meaning we need to ask ourselves somehow, some way, we need to turn that Z to the 4 to become Z squared. Okay, so looking at this thing here, hopefully you guys say that, oh, Mr. Tran, I know that I can take out a 5 because I know that 5 can go into 5, 5 can go to 10, and 5 can go 20, 120. And you are correct. The other thing that hopefully you guys see that you can also take out a Z square, because Z square can go into Z square, and Z square can go into Z to the 3rd, and Z square can go into, let me change the different color, this color. Z square can go into those, right? So what can we pull out? And hopefully you guys say, well, we can pull out a 5Z to the 2nd power. And again, Z to the 2nd power, and if you pull it out, 5 going to 5 is 1 time. Z to the 4 minus Z to the 2nd will give me Z to the 2nd. And 5 going to 10 to give me 2. I still have a Z. And 5 going to 120 to give me 2, 4, right? 24. 5 going to 12 is 2 times. 5 going to 20 is 4 times, 24. So looking at this item here, everybody see that we reduce this item, whatever this thing here is. Let me erase all this green stuff. Whatever this problem is, we reduce it. We make the number a little bit easier, or we make a number a little bit smaller so that we can work with, right? 120, that's a big number, right? 120 times 1, 60 times 2, 40 times 3, and all 30 times 4, and so there's so many multiple. So we don't want to attack with that. We want to make it smaller, and hopefully once you make it smaller, do you agree that this is what we can do? Or what we have is there 2 number multiply to give me 24, but subtract to give me 2. And hopefully you guys say, yes, Mr. Tran, 6 times 4 is 24. We've been using 24 a lot. And again, because we subtract, the larger number will get a negative sign, and the other one will be opposite. So whatever the middle number is, the larger number will get that. And in this case, this is our answer. Okay. So looking at this thing here, yes, the problem look a little bit different compared to the previous one. Is look a little bit different, is look a little bit massive, but we need to factor out the GCF. And once you can factor out a GCF, you can see that your problem is a little bit smaller and is doable, okay? So looking at this item here, if we go into I, well, let me ask you guys, question with G or question with H? Question with G or H here. And again, this is what math is all about, ladies and gentlemen, is no matter how big, how massive of a problem is, your goal is there a way that we can make it smaller? Is there a way that we can make it to something that we know, something that we're familiar with? And if we can, we do it. If not, we stuck with the big problem and we attack the big problem. But now everything that they give you, you can maneuver and make it smaller. So in this case, how can I make this item smaller? Hopefully you guys see that we can take out a 6. And if I take out a 6, how many x can I take out? And hopefully you guys tell me that x to the third power. And if I take out the 6, 6 going to 6 is 1 time. I don't need to put a 1 there, but if you want to feel secure and you want to put a 1, that's perfectly fine. 1 is just hold that place, right? 6 going to 6 1 time, x to the third, 5 minus 3, I still have x squared. And that's what I want. I want to see an x squared. If it's not x squared, we need to maneuver and make it somewhere, somehow to make it a x squared. 6 going to 60 is 10 times. X to the 4 minus x to the third, I still have 1x. And 6 go into 144 will give me 24. And I bring out my x to the third, right? So 6 go into 144. If my math is not correct, let me know. But again, 144 divided by 6 to give me 24. And hopefully you guys see that again, this problem and the previous problem is identical, ladies and gentlemen. It is, well, not really identical, but is there 2 number? We just did 24 in the previous one. Is there 2 number multiplied to give you 24, but add together to give you 10? And again, hopefully you guys say that it's 6 and 4. And because we add in, they both the same sign. And what are that sign? Whatever the sign of the middle number illustrate the both sides. So if you look at this here, if you look at this item here, again, 24, because it's positive, we think in terms of addition, versus this 24 is negative, we think in terms of subtraction. And again, the problem for H and I, the answer is very similar, but yet they are totally different, okay? So looking at this thing here, question with G, H, or I, first we need to take out GCF, make our problem a little bit smaller, and from the smaller problem, we attack it. So if you don't have question, let's take a look at this item here. So one thing is 6.4 is easier than it looks. Well, it's not easier than it looks. It's actually easier than it looks. If I don't give you this title, let's say if I don't give you this title, let's say that I don't say that this is in 6.4. And if you see this problem A, what do you do? Well, if you see this problem A on your test or on your quiz, what do you do? Well, you say, well, Mr. Tran, I know that I need to look at the item. This is what you told me. Look at the C, look at this item. And if this item is positive, I'm thinking in terms of addition. And in this case, this is positive. So I'm thinking in terms of addition. And is there 2 numbers multiplied to give you 36, but add together to give you 12? Well, do you agree? Do you agree that this is what we have is 6 times 6 is 36. 6 plus 6 is equal to 12. And if they add together, they have to have the same sign. And in this case, positive 6 times positive 6 is positive 36. 6 plus 6 will give me a positive 12. And again, is it new? No, nothing new. The only thing new is this, is they say, well, if you have x plus 6 and x plus 6, is that the same as tell me that x plus 6 square? And that's all they tell you is if we have this item, it's basically come out to be a perfect square in the sense that looking at this thing here, all of this problem is in a perfect square scenario. Why do I say a perfect square scenario? Because if last time, if you distributed this item out, you would get x squared plus 12x plus 36. If you remember, take the first term square, take the last term square, put the two terms together and double them up, right? X squared will give me x squared, 6 squared will give me 36, put the two terms together, which is 6x, double them to give me 12. But again, if you don't see it, it's fine. If you don't see it, it's fine. One thing I want to point out that all of this problem here, the last term is positive. And if the last term is not positive, we are in a little bit trouble, okay? So the last term is positive, which is good for us. Why is good for us? Because if the last term is positive, we think in terms of addition. And if we think in terms of addition, do you agree that is there two numbers multiplied to give me 81, but add together to give me 18? And hopefully you guys say, this is a perfect square. And yes, it is a perfect square. 9 times 9 is 81, but now the only thing different is because of the middle term is negative, we put in both of them negative. 9 times 9 is 81, negative 9 plus a negative 9 is negative 18. And again, the only thing that they tell us is we can be fancy and say x minus 9, x minus 9. We can say just x minus 9 squared. And that's it. That's all that they tell you in terms of 6.4, a special factoring item here. And again, hopefully you guys see in C, right? Is C a perfect square? Is there two numbers multiplied to give you 49, but add together to give you a 14? And hopefully you say, yes, Mr. Tran, 7 times 7. 7 times 7. And if you recognize that, all you do is 7. And why do I put in plus here? Because do you agree that the 14 is positive? And again, I don't think they will mark you wrong if you put 7 plus 7 times 7 plus 7, or if you put 7x plus 7 square. Okay, so either or is just tell you that because you have two of them, might as well write one of them raised to the second power. Okay, so again, back then, if you remember, back then is we give you this item and we tell you take the first term square, take the last term square, and put the two together, right? It's just that now recognize this item here. Is this a perfect square? That's what you need to ask yourself. And again, the last two, you can see that this is 13 times 13, 11 times 11, and 5 times 5. You only need to check is 13 times 13 is 169, 13 plus 13 is 26. 11 times 11 is 121, 11 plus 11 is 22. And 5 times 5 is 25, and 5 plus 5 is 10. So if you recognize that, again, all we do is we put x13, x13. What are my sign? Because of this thing here is negative, so they are both negative. And if you want to be fancy, you can say x minus 13 squared. But see how easy this item is. Okay. And again, this item here, you will see y minus 11, y minus 11, and again, y minus 11 square. And lastly, z plus 5, z plus 5. And again, we have z plus 5 square. First of all, question with this special product here. And one thing, ladies and gentlemen, one thing is this. Let me jump to the next page. Let me show you not this item. One thing is, if you recognize, or if you remember, I told you that the last item, let's do 6x. If you remember, I told you the guy that the last item have to be this item right here got to be positive. So if they give you something like this, do not force it. Okay, remember, if they give you this thing here and they ask you to factor, is there two number multiplied to give you 9 and subtract to give you 6x, right? You would say, well, Mr. Tran, is that this item here, x minus 3, x plus 3, right? How do I get -9? Do you agree that to get -9, I have to have one of them positive, one of them negative, right? If you put this thing here, you can see -3 times -3 is not -9, right? And if you put positive 3 and times +3 will not give you a -9. So the only way that you can get a -9 is one of them have to be positive and the other one have to be negative. And if this were to be the case, let's check this thing out. Well, if I multiply this thing here, x times x to give me x squared, x times a -3 to give me a -3x, 3 times x to give me 3x, and 3 times this to give me a -9. And as you can see, what happened to the middle term? Well, the middle term, I have a -3x and a positive 3x, they cancel out. So as you can see, if they give you this problem, ladies and gentlemen, if they give you this problem here, then this problem is prime. This problem, they will tell you that this problem is prime factor because there is no way we can factor this thing out, okay? So make sure that if it's a perfect square, this item have to be positive. This item have to be positive. If it's not positive, you cannot factor them out, okay? And similarly to other problem that I did not mention before, if you were to have something like this, ladies and gentlemen, let's say x squared minus 7x plus 5. Everybody see that this problem right here is also prime factor. Why is prime? Is there two number multiplied to give you 5, but add together to give you 7? Hopefully you say no, right? Because 5, what is 5? There's only one multiple of 5, and that is 5 times 1. 5 times 1 is 5, but 5 plus 1 is not 7. So if you cannot find a combination, or if you cannot factor them out, we just say that this is a prime factor, okay? Meaning there's no way, doesn't matter what this number is, this number can be 15, you can see that this is still prime. There's no way you can find two numbers multiply to give you 15, but add together to give you 7, okay? So it just tells you that if you cannot factor them out, then it's prime. And if you can factor them out, then whatever that factor is, that will be your factor, okay? Now, let's take a look at this item here that we have in 5. I think this is 6.5, not 6.4. 6.5. And what if they ask you to factor out a binomial, okay? So as you can see, this is a binomial. This is the binomial of this item, or a binomial, meaning we have two terms. And factor out binomial is actually easier than it looks, ladies and gentlemen. Factor out a binomial is basically this item here. Is first of all, you have to ask yourself, is the first item a perfect square? And you can see that the first item is a perfect square. Why? Because x times x is x squared. right? Is the second item a perfect square? And you can see that this second item is also a perfect square. Why? Because 4 times 4. And if we can see that the first item is a perfect square, the second item is also a perfect square, all you need to do is fill them in, take one of each, and put in the parenthesis. The only thing different is one of them is positive, the other one is negative. And we just illustrate this item in the other slide just to show you that they are a conjugate of each other. They are the conjugate of each other. And if you want to check it out, as you can see, what do we have here? X times x is x squared. X times -4 will give me -4x. 4 times x to give me 4x. And 4 times a -4 to give me -16. And as you can see, a -4x and a positive 4x, they cancel out. And this is what we have, which is this is my original problem. So as you can see, this is all there is in terms of binomial, and all of your binomial will be in the form of a perfect square. If it's not in the form of a perfect square, meaning if your problem is something like this, let's just say, if your problem is something like this, x squared minus 24, there is no way you can do the problem because the 24 is not a perfect square. In order to cancel out, in order for them to not have a middle term, in order for them to not have a b, right, not have the b term or the middle term, they have to be a conjugate of each other. And in order to be a conjugate of each other, they need to be a perfect square. So let's take a look at this item here. And as you can see, we know that this is a perfect square because x times x. We know that this is a perfect square, which is 6 times 6. And again, this is minus, so it's fit the criteria of the binomial. And if it's fit the criteria of a binomial, all you need to do is you say x6, one of them in each parenthesis. And again, this thing can be negative. It doesn't have to be restricted that the first one is positive, the second one is positive. Or again, it doesn't restrict to, if you put this as a positive, then the second one got to be a negative. Just basically tell you that one of them is positive, the other one is negative. They have to be opposite sign. If they are not opposite sign, they won't cancel out. Okay, so let's take a look at another one, and then I will ask you guys a question. If you take a look at this item here, hopefully you guys say, oh, this is consistently the same, right? X times x is x squared. 12 times 12 is 144. So all I need to do is say x plus 12 and x minus 12. And that is how you factor binomial. And all of this binomial, ladies and gentlemen, all of this binomial is identical, right? This is a perfect square. This is a perfect square. And this, believe it or not, is a perfect square, right? What is this perfect square? Hopefully you guys say that 8 and 8. This here, if you guys forgot, 14 times 14. And again, what is this item? This is y times y. So if you saw that this is a perfect square, all we're saying is x minus 8. If you want to put a minus first, then you have to put a plus at the end. If you see that this is a y plus 14, if you put the plus first, you have to put a minus at the end. Okay, as you can see, all of this item is a perfect square, a perfect square, a perfect square, a perfect square, and this item is a perfect square. What will be my answer for F? Well, my answer for F will be x plus y and x minus y. Even though it's a y, it's basically is a perfect square. So as you can see, this is the answer for D. This is the answer for E. And this is the answer for F. Question with the binomial. before I let you guys go, let's take a look at this particular problem here. You will run into this problem when you do the homework over the weekend, and hopefully you don't get stuttered. If you look at this thing here, first of all, you can see that this is a binomial. So that's check, right? And in the middle is minus, that's check. Everything they minus, check. So now, if you were to have this problem, this is what you need to ask yourself, ladies and gentlemen. Is the first item a perfect square? And hopefully you guys say that, yeah, it's a perfect square. Why is a perfect square? Because this item here, do you agree that 3x times 3x, 3 times 3 is 9, x times x is x squared. Do you agree that this is a perfect square? And y is a perfect square because it's 5y times 5y. So if you recognize that they are a perfect square, 3 times 3, x times x, 5 times 5, y times y. If you identify that, all you need to do is just say, well, they are a perfect square. I just put 3x plus 5y and 3x minus 5y. And that is all I have to do. Doesn't matter if they have a number in front, and I agree with you that this problem is look a little bit different from the prior problem because of this number, or in terms of there is a y square. But ask yourself, right? Ask yourself, is this a perfect square? If both are perfect square, if both of them are perfect square and they are subtract, which is this is the difference of the square, right? The difference of the square. And if it's a difference of the square, and hopefully you guys see that this is what we have, is we have 2x, because 2 times 2 is 4. And this is 11y, because 11 times 11 is 121. And what are my sign? If you want to be a negative first, that's fine. And positive have to be in the back. Okay, so this is what we have if they ask you to factor this thing out. Again, this is my perfect square, 2 times 2, x times x, and this is 11 times 11, y times y, and that's where I have the 2x and 11y. Okay, and hopefully, let me ask you guys for C. Is this a perfect square for C, ladies and gentlemen? 36x squared minus 49. Is this a perfect square? Hopefully you guys say yes. And hopefully you guys say that this is 6x and 6x. And this is 7 times 7, right? 7 times 7 is 49. And if you identify that, all we have is 6x minus 7. I don't know why. Some of you guys like the minus first. So let me do this. And again, if you like the plus first, that's fine. If you do the plus first, just make sure that you have this item as a minus. Again, for me, I like the minus. I like the plus. I always think positive. So I always put the plus first. But again, it's not wrong if you put a negative first, if you are a negative person. Just kidding. But again, looking at this thing here, question in terms of how did we took this item here? How did we took this item 36x squared, and those are my answer? Or how is this we took this item? Because this is what they will give you, and this is what you have to give them in the return. Okay, so in the sense that for this thing here, there's not very much item to dissect. The only thing that you need to dissect is, is your number a perfect square? If it's not a perfect square, ladies and gentlemen, if it's not a perfect square, for some reason, if they give you something like this, don't force it. If they give you something like this, like 2x squared minus 17 or 15. If it's not a perfect square, there's nothing you can do. This is just basically pram. Okay, it's got to be a perfect square. So whenever you see a binomial, two-term, they have to be a perfect square. Okay, if it's not a perfect square, pram. You cannot take the GCF, pram. Okay, so question. Well, if you don't have question, ladies and gentlemen, reminder that we don't have class tomorrow because of the